Speaker today.
Welcome
back to you all. Thank you for being punctual. As Kevin has just pressed the record button. Thank you, Kevin. So this is being recorded. I'd just like to introduce James Esposito from Ohio. He's going to talk about the wealth of the depths, total war, and the diver during the Great War, a dissertation about salvage during World War I. James is a doctoral candidate in environmental history and history of technology at the Ohio State University, and he's a specialist in envirotech, and his research focuses on the history of artificial breathing apparatus and the exploration of extreme environments. So James, thank you, and you're very welcome. And can I remind everybody else to turn off their microphones, please? So James, over to you. Thank you.
All right, thank you. Hello, good afternoon, everyone. I just want to thank Anne and Kevin and everyone else at the HDS for inviting me to give this talk today. As said before, I'm James Esposito. I'm a PhD candidate in environmental history and the history of technology at the Ohio State University. And today we're going to talk a little bit about salvage work on merchant vessels and the role of salvage during the German U-boat campaign in World War I. Just to start off, we're going to talk about sort of the dreary science, British political economy, the economics of merchant shipping, and just Britain's role in the 19th century as a world trading power. The economics of the late 19th century is built around Adam Smith's sort of free trade principles. Free trade is widely popular, not just in elite circles with industrialists, but it actually really becomes a secular religion of the Victorian era. It's thought that if Britain sticks to free trade, prices will be as low as possible, and Britain can focus on doing what it does best, exporting industrial goods to the rest of the world. And this fixated on what was known as the white bread loaf, the idea that wages and prices should allow for consumer access to white bread, which is a little bit higher quality food than would have been familiar to people in Germany with that sort of hard brown bread. It's sort of more of a prestige food fitting for the British public. Britain also is heavily reliant, therefore, on global commodity chains, access to food, but also raw materials for its industry, that sort of thing. And by extension, since Britain doesn't have a great amount of natural resources itself and can't actually feed itself completely during this time, it needs raw materials from the colonies, the empire, the Commonwealth, and even the United States to support this economy based on industrial exports. As a consequence, this expands the British merchant fleet, and it's one of the largest in the world in 1900. On the right-hand side here, we just have a little political ad from the 1840s talking about the corn laws, the idea that this tariff should be gotten rid of to lower the price of grain for everyone. And here we have another little snippet from a newspaper calling for the repeal of the corn laws. This protective tariff is basically repealed in the 1840s, and this is the symbolic moment where free trade has its highest value in British society, where most people think free trade is a good thing. If you're interested in learning a little bit about the social history and everyday life of free trade in the Victorian period and the early 20th century, please check out Tretman's book, Free Trade Nation, where a lot of this material about trade and economics really comes out of. But as I said at the beginning of the lecture, this is not just about economics, it's about sort of the military position of Britain on the eve of the First World War and how they expect to sort of fight this, titanic battle with Germany on the sea. In the Victorian period, the British become the largest navy in the world, capable, at least in theory, if not in practice, to confront two major navies in the event of war. They weren't necessarily sure who they were going to fight, probably the Germans, maybe the Russians, who knows, maybe the French, you know. So they put all their eggs largely in the naval basket because that was, you know, sort of befitting for an island nation. As a sort of consequence, they have a small professional army compared to the really huge conscript armies that the French or the Germans have in the First World War. Britain also can pull on supplies and manpower as well as financial resources from its Commonwealth and Empire neighbors. We're all very familiar with the role of the Anzacs in the First World War, fighting, you know, in Turkey, fighting in the Middle East, Canadians fighting on the Western Front of Vimy Ridge. These famous battles are not just fought by Britons, but by people of the Commonwealth and the Empire. Of course, Britain relies heavily on its banking system to be able to borrow money, raise funds, issue bonds, as well as a pretty sophisticated tax system to raise the money to fight the war. They benefit from having a very decentralized trading network. You know, if they're cut off from certain supplies from parts of the world, they can always make it up by getting food, raw materials from somewhere else. That's the great advantage of having been a naval power. However, it makes you very susceptible to blockade. If the Germans decide, well, we're going to try to starve you out, that's a big threat in the First World War. Britain also has imperial obligations in Africa, the Middle East, and in Asia. So it's not just defending the home islands in Western Europe. It has to have pretty significant military forces around the world because the Germans or the Turks or some of these other powers are going to try to unseat Britain in the colonial spaces. And here we just have a photo of the King's Review at Spithead in 1914, just to show you, you know, the investments that are made in terms of naval power. Really just an enormous fleet here with large modern battleships, the Dreadnought class battleships of the day, and really quite impressive in terms of scale. Here we have just a map of Britain and its colonial and Commonwealth responsibilities during this time. Again, it's not just Australia, Canada, New Zealand, but you know, the Indian Empire, the Sudan, Egypt, and Southern Africa. So there's a huge amount of responsibilities to keep this system going. We have to also think about the British Empire as being an empire of infrastructure. The railways and shipping are really, really important because if you don't have railways, you don't have rapid transport. The grain or raw materials you're going to get from the ports won't be efficiently distributed. So prices, let's say in Glasgow, are going to be a lot different than they're going to be in London. You know, people living on the South Coast or in Wales are going to have much higher prices if there isn't a cheap way to get everything around. So the railways and shipping are really, really important to this free trade mantra, and obviously very important to the war in general. The British spend a lot of money originally not investing in the Suez Canal, but they do gain a hold of it in the 1880s. And that really, again, makes the empire even more important because you can get that route to India very easily, as well as the telegraph. You know, Britain has its own telegraph network around 1900 where it can communicate without even going into other powers like Russia or the European states. It has its own telegraph network that comes online around 1900. So it can communicate with Australia, India, across British-held islands, territories, etc. So in order to keep the system going, you have to have a circulation of commodities. It keeps the home side, the home fires burning. People need food to eat, to produce the armaments, the weapons to fight the war. If you get cut off from these resources, you're going to face starvation. and even problems supplying your military. And you have to have these exchanges between this home market and the rest of the world. But even in the best of times, even in peacetime, lost or wastage of commodities is a factor. So ships can crash into each other and sink. Vessels can be lost in adverse weather conditions. There are all kinds of things that will affect where commodities are going, how much it costs for them to get there. One of the things that we should think about also when it relates to diving is sort of nature and act of God. In particular, sunken ships sunk by accident or in bad weather, bad navigation, that kind of thing. So having an underwater recovery capability is a huge asset. We don't usually think about commercial diving as a military asset, but during the First World War and the years leading up to it, being able to recover things from relatively deep water is hugely important. And recovering commodities as well as perhaps secrets from German U-boats, either technical secrets or information on their codes, becomes very important during the German U-boat campaign. So I want to put forward diving as a flexible infrastructure. Diving really is a connection of the surface world of commerce to the seafloor. Before diving becomes a big profession or relatively important profession in the mid-19th century, ships and cargoes, once they're lost, they're really lost from these commodity trains, this sort of world of markets and capitalism that's going on the surface. But once you have diving, you can actually get valuable things from that were previously thought to be complete write-offs, right? Even if an entire ship can't be saved and refloated, the diver has the potential to retrieve precious cargoes with minimal capital expenditure compared to running a railway, building a canal, getting divers down there to get some of these resources is relatively inexpensive in comparison. Therefore, the insurance companies really get into salvage, and they use this as a way to recover some of their losses. So if you're going to have to do a huge payout to a shipping firm, those who have the cargo on these ships, you have to pay them back for these insurance claims. One way to defray these costs is to send divers down and get the most valuable stuff. So gold bars, silver, etc. On the right-hand side here, we just have a 19th century little magazine ad with some Royal Navy divers. And it just says down here, diving for work and treasure. There's a lot of people that would have learned to dive in the Royal Navy and then brought that back and worked as commercial divers. And it's important to think about, even from a pure military standpoint, diving is a skill that people are learning. Slide. So what are the economics of ship salvage in the 19th century? Well, in the 1850s, 60s, and 70s, salvage companies are very small operations, often the second job or even third job of fishermen, harbor laborers, pearlers, or oystermen, people that work on the coast and people are familiar with the sea. But by 1880, this begins to become a little bit more formalized and associated with insurance. So the London Salvage Association is established by Lloyd's of London to conduct surveys, evaluation, and cost of salvage. Again, with the idea to recoup as much as possible from lost ships. If Lloyd has to pay out for a ship that crashes or is lost in a storm and sinks, they want to be able to have someone that can assess, can you save this thing? Is it even feasible to even recover this ship? Or should we just write this off and say, we're not going to deal with it. We can just build another ship. We can actually pay out the the shipper and have them build another ship in port. Companies began to specialize in this delicate process of refloating and removing valuable commodities on ships with what were known as no cure, no pay contracts. So salvage firms are only paid after the value of the ship is recovered to the satisfaction of the underwriters. So if you're doing all this work, diving, trying to recover a ship or its cargo, and people are hurt and you fail, or the ship is too damaged to recover, you don't get paid. So for wide sort of state, the salvage companies are always in the back foot compared to the insurers. Nevertheless, it becomes a very important part of the economy leading up to the First World War. The company I'm going to talk to you about today is the Liverpool Salvage Association, and they were the largest company at work between 1880 and 1919. It was managed by Frederick H. Lowe, who had worked in the shipping industry, but these salvage operations were conducted by this gentleman here, Frederick W. Young of Liverpool. And Young gets essentially drafted into the Royal Navy during the war. The Liverpool Salvage Association is familiar with doing the salvage work, and the Admiralty sees that, oh wow, like the Germans might try to sink our merchant shipping, and we might even need these people who have experience with salvage to recover some of our larger ships, maybe destroyers, cruisers, if and when the time arises. The firm itself was not principally a money-making operation, but again represented the needs of the underwriters from the insurance companies, as well as people who own ships, who might have wanted to recover some of their investments in the event of accident or some sort of misadventure. And here we have a quote from Frederick Young from 1905. "The commercial aspect must always enter into any calculations he may make, and the method adopted must necessarily be regulated by the value of the article to be saved. The modern salvor is thus faced two important considerations. He must regulate his expenditure within these bounds and decide on the spot whether the cost of his plan of operations will be repaid by the results he can reasonably hope to achieve." So essentially he's saying here that you have to think about the commercial value, the time that you're going to spend on labor, equipment to recover these wrecks, and make very quick decisions on whether you're going to actually try to save any of these ships or their cargoes, because every second you wait takes up more money, takes more time, and you're not going to get that back. So you have to be very, very quick on making these decisions, while also considering the engineering problems of taking a ship from underneath the sea or rescuing some of this cargo. So the LSA actually assembled its own fleet in the years before the First World War, had a ship called the Hyena, its main ship, the Ranger, which had big, huge workshop space, and Linnet, which was another smaller vessel that was used for salvage operations as well. Ranger was really the biggest ship, and it was essentially a workshop on the sea. It had salvage gear, it had air compressors capable of pumping out over 5,000 tons of water per hour, pneumatic tools for divers, mooring cables, anchors, big 50-ton purchases, which are sort of like naval cranes, towing gear, and that sort of thing. But it also housed a lot of the human capital that you need to do a successful salvage operation. And that's divers, of course, but also carpenters who are useful for making cofferdams when you're trying to recover some of these sunken ships, and mechanics. So if you have a ship that you want to get you need to have mechanics on staff to basically get this thing up and running, or at least make it safe to tow into harbor so it can be repaired more completely. The ship also had facilities to carry pontoons, which were very useful for increasing the buoyancy of wrecks. Essentially, you would use cables to connect the pontoons to the hull of the ship and lift it and tow it out of its place on the sea floor. And here we have a photo of the Ranger. Again, it doesn't look like much from the photo, but in terms of a salvage capability, this is, top of the line in terms of what Britain has during this time. And here we have the Linnet. The Linnet was a little bit smaller and would do smaller vessels during the First World War. So how did these salvors try to recover ships in this era? Well, they had a first was patching and pumping. Essentially, this was the cheapest way of doing it. You would send divers down to locate and assess the damage on the ship's hull. If it wasn't too bad, the diver would be tasked with filling the hull or holes on the side of the ship with wood planks and some sort of sealant like tar or oakum to kind of fill in that gap. Then they would bring cement down and pour cement on top of that to make it strong enough so the ship didn't, fall to pieces on its way back to the shipyard. Occasionally, they would also put steel reinforcement plates to stiffen this patch, giving it, kind of almost like a bandage for the ship's hull. Divers then would be tasked with going through the ship and closing all the ingress points, the windows, the doors, and the bulkheads to return the vessel to a watertight state. And then the surface would bring down the hose to essentially pump the water out of the ship and try to get it to float. And this method was designed to be pretty minimally invasive to return the maximum value of the ship, leaving it largely undamaged for its return to port. Of course, you can't always do that. We don't live in an ideal world all the time, so there are other methods of going about this, and coffer damming was one of them. So a coffer dam is essentially a wooden structure, a set of walls near a ship that has sunk in relatively shallow water. Divers were sent down to construct the structure around the ship with help of the carpenters on board, and they would use cement or wood to make a set of walls to isolate the ship, and then they would try to pump it out. Of course, the principle of time is money is a very important consideration. Building a coffer dam takes time. It takes a lot of resources to do that. And although in some ways it would be more convenient to do some of the repair work on the hull or do engine work, it was very expensive and it wasn't done all the time. And then the final method, and really the most dangerous and invasive method, was the use of pontoons. Pontoons would float on the surface, on the sides of the vessel, and then divers would go down with pneumatic drills and punch holes in the hull, running these wires through the ship. And then they would go into the center of the ship, link them together. Well, sometimes the structure inside, the rooms inside, would prevent this. So they would have to cut through that, either with a pneumatic drill or small explosive charges to link these chains together. And you would have to do this several times to make it strong enough for movement through the water. And actually, Young had a situation in the early 1900s where he had a ship, the Sarah Bra, he was trying to recover, and essentially he had the divers put the chains through, and then he lifted the entire merchant vessel and then moved it, towed it to the shipyard completely underwater. So our Ranger was towing it, carrying it up by these pontoons, and the merchant vessel just went through the sea completely underwater until it was recovered at the port itself. was pretty remarkable and also really quite risky and dangerous. And this was only reserved for the most valuable vessels that the owner or the insurance company wanted to recover intact. And here we just have a period picture from around 1900 of a sunken ship being prepared for a patch. So divers would go down on the opposite side of the ship and try to patch it. And here we have cofferdam. As you can see, like building a cofferdam is a quite considerable engineering achievement, and it does take a lot of time and energy. And as you can see very, very smallly in this photograph, the divers and their helmets, as well as their lines to the surface. So you can see that even though there's not a ship in here right now, this sort of area is where the ship would be drained and recovered. And here we have an illustration of what the pontoon system was like. Again, the divers have to sort of go underneath the hull, dig out a section, and then punch through with pneumatic drills, and then run the cables around. And of course, this could be a very dangerous and risky endeavor, and there's no telling what damage is going to be on these ships. That's why you really have to have skilled divers to tell you that, okay, like this could probably make it to the surface, or could probably make it to the shipyard without breaking itself apart. Here we just have an illustration of one of Young's recovery efforts. This is the HMS Gladiator. This was a protected cruiser of the Royal Navy that crashed into an American steamer off the Isle of Wight in a snowstorm in 1908. So it got the worst of that collision and went to the bottom. And this is what it would look like with the pontoons to increase the buoyancy. And it would pump it out, put it in a patch, and sort of tow it back to the shipyard. And this was used somewhat during the First World War as well. We also have to keep in mind that the environment, the underwater environment, the mercy of the sea and underwater ecology is going to affect the value of these ships and their cargoes. So every operation is at the mercy of the sea and the weather. If environmental conditions on the surface, like weather, tides, other adverse conditions can increase the costs of operations by over 200%. So if the current's too much, you can't go and do salvage work as divers. So you have to wait for the conditions to improve. It's going to be harder to do the engineering work and do a profitable salvage operation if there is difficult environmental conditions. And of course, the conditions in the North Sea and the English Channel really could make it quite difficult for humans to recover value from these ships. And this was a really important limitation to what was done in the years up to the First World War. Once the calculations of the conditions, the time of year, that sort of thing are put in, recovery operations could be canceled just because they thought it would be too much to wait and try to delay these salvage operations while these people are on the clock, as it were. And there's always the possibility of the undersea ecology to destroy the ship. There's going to be living matter down there that's going to not only contribute to rust and corrosion and damage, but there's also going to be the process of trying to remove deposits of sort of sea life that's living down there if you're going to try to bring this thing up intact. And this could easily incur a total loss. Again, the price of salvage could remain the same, but the construction of a new ship in port would often be less expensive than the additional costs imposed by weather delaying a salvage operation. Again, these are most important in peacetime operations because, well, the economics are a little bit more straightforward. But war changes the game. This is particularly important in the context of World War I, as the conditions of the production of new ships is rapidly outstripped by the losses being incurred by German U-boat attacks. So, in peacetime, the calculus of trying to recover a downed ship from the bottom of the ocean are very different than what's going on in wartime. If you're losing, 10 ships a week, 20, 30, you're going to rethink the value of those wrecks. And certainly that's what happened. War losses really transformed the political economy of trade in the British Empire. The loss of friendly merchant ships created the threat of starvation and material scarcity. So it's not just food. Food is very important because obviously if there's no food, the people are going to demand the end of the war, but also material scarcity. If you can't get the metals you need, you can't get guano for the production of explosives and for fertilizer, you're essentially cutting off the nation to its global trade network. And Frederick Young was really pivotal in mobilizing Britain's salvage skills and the technology to extend the war effort, especially in the years of renewed unrestricted submarine warfare from the winter of 1917 to the very beginning of 1918, where the Americans aren't quite in the war yet. They're trading, but even then, the Americans are not going to be able to do that much until really that autumn of the following year. So this is really a delicate time where Britain is taking a lot of losses on the merchant ships and submarines. The Royal Navy is struggling to identify them, as well as their minefields. Germans will be very sneaky and put in minefields in the channel and not tell anyone, of course. So there's a lot of problems with the shape of the ships that they have. And here we have just an illustration of the ships sunk by U-boats from February 1918 to January 1918. So it's a considerable amount. However, there's actually quite a few in coastal water. So these are diveable wrecks that if they're not too old, not too damaged, maybe they took a mine hit or torpedo hit, you can attempt to recover them. And actually, Germans produced propaganda postcards with all the sinkings from their submarines, which would have been distributed throughout Central Europe. And again, a way to raise funds, but also sort of rather quite cold and quite, horrific reminder of the toll that the U-boat is taking on the British merchant fleet and the people that have to, work these jobs. Here we have just a graphic of the big increase in shipping loss due to the U-boats. That spring of 1917 is really a critical time. As you can see, it's sort of going up, but earlier in the war, yes, you're losing ships, but the need to salvage isn't quite as high. Of course, this is also a period where British shipyards are trying to push out as many merchant ship replacements as possible. The government is essentially bankrolling Lloyd's to keep the insurance rates relatively, affordable to keep these ships running. But also, make sure that Lloyd's doesn't go bankrupt. So this is a very critical time and very important to the war effort. And here we just have a illustration or a photograph. Look from a U-boat having recently sank a British merchant ship. So the theme of this lecture is wartime salvage, and I'm just going to talk a little bit about the numbers here. So in all, 500 of the roughly 3,500 British merchant ships were salvaged by the end of hostilities in November 1918, with approximate value of £50 million. The recovery of food and materials happened at a critical time, helping prevent starvation during the renewal of unrestricted submarine warfare. In order to keep the food going, to keep Britain in the game, and to keep sort of domestic sort of home front politics on the side of the war, they have to do whatever they can to get these merchant ships up and running. The shipbuilders, of course, are exhausted and they can't keep up these losses. They're putting out new merchant ships, but it's not enough. So there's a huge need for salvage to avert starvation. And the most important part here, and really the most important part of this lecture, is many salvage operations would not have been economical otherwise. It's just the demands of the war economy, the distortions of total war, the destructions, and the losses incurred by the Germans are changing how people even consider what is a valuable wreck, what is feasible, really pulling at the limits of salvage as a valuable and really useful method of trying to recover some of this capacity. Here we have just a torpedo strike on a British merchant ship. As you can see, this is a significant amount of damage that would easily take down a merchant vessel, but this vessel was salvaged, and quite a few were. And here we have just an image of electric vacuum pumps. And again, these are invented around the turn of the century, and this allows for pumping out 5,000 tons of water at one time. So reducing the amount of time needed to do these recoveries. One fascinating episode is one British merchant ship that was salvaged and patched after being attacked by a German submarine was then attacked again on the way back to port. It was therefore sunk twice, but the salvors got back to it and then patched it and refloated it again. So this essentially was down by the Germans twice and recovered twice. Eventually, this ship was beached on the Isle of Wight and then returned to merchant service after it was repaired. An important technological development during this time is what was known as the standard patch. Young developed a standard patch, a prefabricated wooden patch used to quickly and easily convert vessels that had been damaged. So instead of sort of doing it vessel by vessel basis, he essentially created a standardization where he could, punch out the standard patches, go to the site, have the diver put the patch in, and then get to the process of recovering it. And this could be applied in most situations, obviously not all of them, but it was roughly the dimensions of an expected torpedo or mine strike, so that that also helped with the efficiency. I'm just going to give you some examples of some famous salvage operations to just end this lecture. My favorite is the SS Westmoreland. This was a refrigerated steamship that was produced in Glasgow. It was coming off a trip from Australia, refrigerated, carried both rabbits and approximately 80,000 boxes of butter on its way home to Liverpool. It was sunk by the German submarine UB-57 just outside that area. Basically what happens is Westmoreland is settles at sort of low tide, it's listing, and submerged in 30 feet of water. And then the people of Whitehaven in Cumbria come out, they go to the beach, and they see a mass of dead Australian rabbits on the beach, interspersed with sticks of butter from the ship's hold. These foodstuffs kind of floated ashore, and they were recovered by the townspeople and distributed to the local markets in the area by officials from the Coast Guard. Westmoreland was a refrigerated ship and was carrying quite a bit of butter. And many of you might know that that was one of the big shortages in the First World War, was lipids, having this extra fat in one's diet to even out the nutritional deficiencies. The Admiralty finds out about this and is determined to recover 3 million pounds of butter. They go out in February, bring the divers out there, they refloat the ship, and they empty it of this food, this butter. Some of it had gone rancid, but the vast majority of it was deemed good enough for consumption during the war, and is sold in that February of 1918. Here we also have the example of SS War Knight. War Knight collides with an American fuel tanker, the Jennings, off the English Channel. Jennings is full of gasoline and oil. War Knight is full of naphtha, which is another petroleum product. The Jennings is shot down by the Admiralty because they're afraid it's going to make even bigger explosion. The Admiralty takes War Knight and actually recovers the hold, the very valuable and volatile fuel. The naphtha is taken off War Knight and recovered. And then just to end this lecture, we shouldn't limit our idea of salvage just to physical items like that rancid butter or this fuel or the ships themselves. The Admiralty's got so much experience with the salvage operation that they moved to U-boats. In the early part of the war, they recovered 2 U-boats, and this got the Admiralty to start thinking about naval intelligence and decryption. And by the end of the war, GCC Dammit, a professional diver and actually a future friend of JS Haldane, works on the salvage operations to get valuable radio codes from German submarines. They also get really valuable technical intelligence. So they get the setups and arming mechanisms for mines, so the British can build their own minefields, as well as really valuable maps for minefields. So one thing that is really important here is that they're not just recovering stuff. And it's not just the war economy that makes the value of things that would never be economical in wartime valuable, but also the idea that wartime brings these people, these organizations to need to recover information that the Germans think it's just gone, it's not useful anymore. And it causes the Admiralty to try to get to these submarines almost immediately after they're sunk, because if they wait too long, the Germans will change their codes, they'll move their minefields, that sort of thing. Here we just have a salvage operation on a coastal submarine that was U-44. And then finally, just to finish up here, again, this is bringing information back into circulation. These code books brought information back into circulation, and then we're now under the control of the British. So what was sort of German, specified knowledge is recovered and given to the British. And this simplifies the Navy's anti-sub work and isolates and cripples Germany's capacity to operate against Britain's merchant fleet. So if they can get these codes, get this information back, recover it, they can actually go on the offensive against the U-boats. But again, it is a time-dependent factor, and sometimes they would run into a thing where it would be an old U-boat and it wouldn't even be worth salvaging. But yeah, thank you so much for taking the time to listen to this talk. I welcome any questions, comments. Thank you.
We just open it up to questions now. Anyone? Any questions? But while you're thinking about it, then I want to thank James for a fascinating paper, really well presented. For me, James, you've proved Einstein's theory that everything in the world is connected, and seeing this explanation of the British Empire's dependence on the Corn Laws and the White Loaf Principle, and the what do you call it, the circulation of commodities on which the British Empire depended, leading to the emergence of a critical diving capability, and that picture you showed of 500 UK ships lost around the coasts of the UK. It's really, really sobering. And, you know, the enormity of it, of 500 ships having been salvaged out of a loss of 3,500. I enjoyed it so much, and I've learned a great deal from it, and I really thank you for that paper. So any other comments or questions for James, please?
Well, I'm just looking at, I remember that photograph of the Navy. Blimey, Teddy. I can imagine what we live off. We just live off where the fleet review would have been. That must have been an amazing sight back then.
Yeah.
That must be equivalent to all the navies in the world put together today.
Oh yeah, easily.
Yeah.
It looked as though it was photoshopped, I'm afraid. There were so many boats there.
Yeah. It's very interesting.
I think Gary has a question.
Yes, it's a very interesting talk and very concise. And your knowledge of the 19th century economic history, it's amazing. And I just wonder, I don't know whether you're American or Canadian, but was there a similar problem within America or Canada about the losses of commercial shipping, which we haven't heard about?
Yeah, so I am American. You know, sometimes I want that Canadian passport, but yeah, no, I'm American. Yeah, so the 3,500 ships those are the British flagged ships.
Yeah.
But there's about 1,000 more that are taken down from the neutral powers. There's actually a lot of work have been done about the United States during World War I, and the US is sort of neutral, right? You know, but we don't sell any weapons to the Germans. We sell tons of weapons to the French and the British. And, you know, when the Germans are saying, okay, what was you know, destroy, you know, famously the Lusitania, which doesn't immediately bring the US into war, but it makes enough people really angry to sort of start that idea that, oh, the Germans are not our friends. And then, you know, the arms dealers essentially are upset when they lose, you know, consignments of these weapons. You know, that the Allies would have ran out of arms in 1915, maybe early 1916, if they didn't have the American factories. Actually, the British and the French get the American gun manufacturer Remington in Connecticut. They build a whole factory for them. So they say, okay, well, we don't have enough capacity, we don't have enough people, we'll just buy you a factory in Connecticut. And it's still there today. So there's big money in that trade, and America is definitely a part of it. Did that help? I don't, you know.
No, I'm grateful for the fact that you recognise the British contribution to both world wars, which we don't always get in this country, but you're being extra kind to us, and thank you for that.
He's a friendly American.
Yeah, I love England. England, like, yeah, it's great. Yeah.
He's been over here and been to the museum, so he knows how we operate here.
Nigel, did you have a question?
Oh, dear.
No, Mike, that was Bill's question.
Okay, right. Okay. Are there any other questions for?
It's not a question,
James?
it's just a comment. You know, I keep forgetting that all of this salvage work was done in standard dress.
Oh yeah, I should have talked about that, but I was at 41 minutes there, so I was like, oh well, you guys know about that stuff, so
Yeah.
But in this is a dissertation chapter that's being turned into an article, and it has more of that material on standard dress, what it's like to be diving, you know, the environmental and physiological problems of diving, that sort of stuff that I love. But I figured that I would just give you guys a little bit of the sort of the stakes kind of big picture.
Yeah.
There was one thing I suppose you could have added to it, was that a lot of that salvage work would have been done in minefields as well.
Oh yeah, oh absolutely.
Which makes it doubly dangerous, not just getting attacked, but you could hit a mine. In
Dament's reports to the Admiralty, he talks about how he's doing salvage work, trying to get these codes, and they're German submarines lurking around, and they know that they have to get these codes immediately. They have to get the maps very, very soon. So he's always afraid that they're going to blow him up essentially with a torpedo while he's down there, or his people are down there.
Yeah.
So I mean, that's a huge thing. One of the things that we talk about in our program, because I study under a historian of World War I and an environmental historian, we think about the sort of porous distinction between who's fighting these combatants and the non-combatants. So like, divers are non-combatants essentially, but if the Germans decide that they're going to blow these ships up, they kind of become combatants. It becomes very porous, right? The rules of war, who is and isn't in uniform, that sort of thing gets a little bit kind of skewed at this point, and that's what makes it really fascinating and useful to work on.
Mm.
Excellent.
Hey, any more questions for James? If not, I just want to say on behalf of everyone who's watching and the HDS, thanks to you for a fascinating talk. You've given us an understanding of our history that I certainly wasn't aware of. Being able to understand the link between the Corn Laws and the development of diving and salvage capabilities is absolutely extraordinary, and I'm very grateful to you for it, James. So round of applause for you from around the world, and thank you so much.
Yes, no, I'm so glad that I got a chance to present today. It's always great to talk to you guys. You guys are so smart and so interesting, and I love working with Ann and Kevin and everyone else. So yeah, I'm looking forward to the next talk if there are no other questions.
Yeah, James, sorry, I don't know if you realize, James, you actually have people from Australia on here and people from different countries in Europe as well.
Oh, wow. What time is it in Australia? This is Patrick, what time is it there? What day is it there?
Where are they?
I think it's tomorrow there.
No, it's still today here. We're at 30:30 in Perth. We're 11:30, but in Sydney you're 2:30 in the morning the next day. So they're a little way away from us. Most of them have gone. I can't see any connected. They go to bed early in Sydney.
Well, look.
Thank you very much.
Thank you.
Yes.
Yeah. So as we can stick to our program, we've got one more speaker today, and just to be fair to everybody, we'll stick to the program. So at 1600 UK time, which is in about 27 minutes time, we'll start the next talk. So Kevin will close the link now, and he will reopen it at about 10 to 5 UK time at 16. That's right, isn't it, Kevin?
10 to 4.
10 to 4. 10 to 4.
Also, I'll leave it open so people can chat as well.
Okay, and after the last speech, you're going to leave it open so we can have a general chat. That's absolutely brilliant. Okay, thanks again, James, and we'll see you when we all log back on again. Thank you.